Hello friends, let's begin with today's class, lecture number 27. In this class, we will be covering the sequence impedance and networks of power system element alternator, and we will be covering the negative sequence network and the zero sequence network. After this class, you will be in a position to draw the sequence diagram for the positive, negative and zero sequence network. So as we have studied in the first module during lecture number 6 and 7, where we were in a position to draw the sequence diagram or the not sequence diagram, the impedance diagram and the reactance diagram, and its further modification after this class is the negative sequence network, positive sequence network and zero sequence network. So one impedance diagram or a reactance diagram can be broken down into positive sequence, negative sequence, zero sequence for each component. Mind it, for each component which I say, that means it is for a synchronous motor, it is for a synchronous generator, it is for a three phase transformer or a bank of three single phase transformer or a transmission line. So for each component I can draw, or we can draw, the positive, negative and zero sequence component for each device or each component. So this will help in analyzing the faults for the entire power system as a network. So the contents covered here are the knowledge of, in the previous class it was the knowledge of positive sequence network for a synchronous generator. Now in this, negative sequence network is a general or quite similar to that of the positive sequence network, except that since no negative sequence voltages are generated, the source of EMF is absent. Therefore, the equation for the negative sequence component is given as VA2 is equal to minus IA2 into Z2, where VA2 is uh, the terminal voltage and EA2 is the self-induced EMF, and IA2 is the current in the negative sequence component. Further, the zero sequence network will be free of internal voltages and flow of currents resulting from the voltage at the point of fault. Impedance to the zero sequence currents are very frequently different from positive or negative sequence current. Transformers and generator impedances depend upon the type of star or delta connection. The zero sequence impedance equation will come out as VA0 is equal to minus IA0 into Z0. Uh, Coming to the next component, that is a transformer. Here the positive and negative sequence impedances are going to remain same, which is nothing but equal to the leakage reactance, that is Z1 is equal to Z2 is equal to ZL. Whereas the zero sequence equivalent circuit of the three phase transformer requires special attention because of the possibility of various combinations. Because when we consider the three phase transformer, there are two connections that are coming into picture, star and delta. So there may be various combinations of these connections. It may be a star star, it may be a star delta, it may be a delta star, it may be a delta delta, it may be a star three phase four wire system with a delta, it may be a delta with a three phase four wire system star. So these many combinations will be available, near about some 14 to 15 combinations are available, and each combination will have its own zero sequence network separately. So Z0 is the zero sequence impedance of the line of the windings, not line, sorry, of the windings of the transformer. Here there are two series and two shunt switches in the transformer. One series and one shunt switches for both the sides separately. The series switches of a particular side is closed if it is a star grounded, and the shunt switch is closed if that side is delta connected. Otherwise they are left open. So I will repeat again this particular line because this is what is one has to apply while drawing the zero sequence impedance for three phase transformer. one series and one shunt switch are for both the sides separately. The series switch of a particular side is closed if it is a star grounded, and the shunt switch is closed if if that side is delta connected. Otherwise, they are left open. So please consider this particular slide. As the transformer is a static device, the transformer is independent of the phase sequence of the applied voltages. Therefore, Z1 is equal to Z2 is equal to X leakage. And PSN and NSN for the three-phase transformers are as shown in this particular figure. Zero sequence impedances will be equal to positive or negative sequence impedance if there is a path for zero sequence current, and will be infinity if there is no path for the zero sequence currents. The following are the observations. If the neutral or star point in the star connected winding is not grounded, then there is no path for the zero sequence currents in the legs of the star connection. Second point, no zero sequence currents can flow in the lines connected to a delta connection, as no return path is available for these currents. Zero sequence currents can, however, flow in the legs of a star. Such currents are caused by the presence of zero sequence voltages in the delta connection. So in this particular figure we can see two series switches and two shunt switches, and in between there is a zero sequence impedance. Now here comes the slide, which is a concise and very important slide showing the various connections, their various connections, that is star delta connections, their connection diagrams, and the zero sequence equivalent circuits. So please consider the first one, that is a star star. So it's immaterial whether it is a star with a solidly grounded or it is just without any ground. So please consider the first one, that is star star. So it is a rule that has been told, that just I will repeat the rule. I'll come back to the slide again. The series switch of a particular side is closed if it is a star grounded. If it is a star grounded, it is closed if it is a star grounded, and the shunt switch is closed if the side is delta connected. Now I will come back to this slide again. Now in this, the primary is star grounded, so what will be the series switch now? So in this case, as it is grounded, the series switch is closed. Yes, you can see that the series switch is closed, and the delta, as in the secondary, it is only star, so it is open. And as there is no delta connection, the shunt switches are being open. So what we have is only the primary, we have the closed connection. Consider the second one. In the second case, it is star star, that two grounded, both are grounded. So when both are grounded, both the series, that is primary as well as secondary series, will be closed, and as there is no delta, the shunt switches will be open. So we can see that between the primary and secondary, the zero sequence impedance Z0 is connected. Next is star grounded delta. So primary is star grounded and we have delta in the secondary. So as it is star grounded, series switch will be closed and the shunt switch will be open in the primary, and in the secondary, shunt switch will be open and the series switch will be very sorry, the shunt switch will be closed and the series switch will be open. Next connection, that is star, simple star and delta. So as it is a simple star, series again open and series is open, then the shunt is open, and in the secondary, as it is a delta connection, as it is a delta connection, it will be, the shunt will be closed and the series will be open. Next, delta delta, delta delta, we can see that as both are delta, shunt, both the primary and secondary shunt switches will be closed and series switches in both are open. So these are some of the examples that have been given in this particular diagram. So if you have understood with the rules, so I am putting a question for this particular slide that there is one mistake. So by next class, please find out the mistake and let me know. What is the mistake in this particular slide? If we have understood with which series are open and which switches are open and which switches are closed. There is one mistake in this particular slide. So if you are really understood with these rules, then you will clearly identify that where is the mistake in this particular diagram. There is one mistake. Okay, so the mistake will be told in the next lecture notes. So till then, identify which is the mistake. So I am leaving this as an assignment for you people. So please find out. So where is the problem, right? So like this you can make various connections. Apart from this, I think in this we are not done with respect to delta star. So you can try with delta star, you can try with only star star. So we can go for some 14 to 15 connections and draw these types of zero sequence equivalent circuits. So coming to the end of this particular class, here by this class we have understood that how we can draw the positive, negative and zero sequence networks for generator as well as the three phase transformer. Thank you.